Alrighty. Well, I'm sure more folks are going to be funneling in slowly but surely. But just to get started, so again, thank you all for joining the Tufts Research and Data Symposium for Food and Nutrition. Right now, we're going to have a nice workshop on constructing visuals in R using ggplot by Dr. Meghan Hartwick. Meg is both a colleague and a friend, and I'm very excited that she could join us here today. Dr. Hartwick completed her PhD in 2019 in molecular and evolutionary systems biology. Her research integrated population genomics and statistical modeling to develop predictive models for water and foodborne human pathogens. She was introduced to the field of data science during her collaborative work at Tufts University, conservation medicine in 2012, and she has also worked with infectious and non-infectious disease data modeling in human and wildlife populations with Woods Hole Oceanographic Institute, the Northeast Loon Mortality Project, and as a fellow at the Tufts Initiative for the Forecasting of Modeling and Infectious Diseases. Dr. Hartwick currently serves as a fellow in data science through ORISE at the NIH, where she's continuing her training to develop quantitative solutions for public health challenges from emerging infectious disease. With that, I thank you all for joining us. And now, Meg, take it away.
Okay. Hi, how's everybody doing tonight? All right, let me go ahead and get my screen up here. Hold on. Share screen. And you can see behind the curtain. Okay, can everybody see the first slide? It says data visualizations in R with ggplot. Great. Well, Ryan, thank you for that wonderful introduction. Little side note, although I am currently a fellow with the NIH, this presentation does not reflect the NIH, and there was no funding from the NIH for this presentation. Got to put that in there. I was really excited to be invited to develop this workshop for this symposium, and I'm really looking forward to jumping into the materials with you guys. I realize it's a little late in the evening, so hopefully, like me, you have something to carry you through, and I'll try not to keep you too long today. The way I am kind of perceiving this or see this is that I'd like it to be as informal as it can be, as if we were actually in a classroom working together. That being said, there's certain things that I'm just not going to be able to help troubleshoot today. So as we get the materials up and running, if you're having trouble getting your RStudio environment set up or packages loading, we're not going to be able to troubleshoot that. And I'll give you some advice on the materials you can use. And likewise, if you have questions that are of a broader scope or don't pertain to the slides or problems that we're currently working on, let's try to save those for the end, because I may have been a little ambitious in how much material I prepared today, just a little bit. Okay, so let's jump right in. And if my screen will allow, I'd like to advance. Great. Okay, so if you have not had the opportunity to yet, this is your opportunity to head over to my GitHub page. It's Meg Hartwick, ggplot workshop 2. Ryan, feel free to throw that link in the tab if you want. I'm going to jump over and show you what that landing looks like. And this is going to be my first attempt at screens hopping. I'm going to be doing a lot of screen hopping today. Okay, can everybody see my GitHub page? Thumbs up. Yes? Great. Okay, cool. So this is where that link will take you. You will see up here, there is a folder called Tufts Friedman ggplot workshop. As the markdown document says, click on the green code button, download as a zip. Okay, from there, now you're going to get to see how wonderful my downloads file folder looks. Click on that. It opens up. Oh, open. Open, and now you have a selection of files. So as it says on the Markdown page, these range from very interactive to not interactive at all. If you want to just follow along via an HTML document, these two are your choice here. So you can click on one of those. And what this is just an R Markdown HTML page, right? So this is the code that we're going to be running through. You can't run anything, but you can see what the code is, and you can then see what the output is of that. If you're feeling a little bit more ambitious today and you want to try out some like execution of code, go ahead to this RMD file and you want to open that. And I've got my environment set up so that the RStudio is the default. But if you do open with and you select RStudio, it will open this. Alternatively, you can go to your RStudio and open it from there. So when we open that, this pops into my RStudio environment. And now we can see we have a different view than that really pretty R Markdown HTML page. But
hey, Meg, you can
yeah.
just only see your GitHub right now, but it seems like maybe you're trying to have our studio screen on, but we're just seeing the GitHub page.
Thank you. Like I said, I'm doing a lot of hopping. Can you see the RStudio now?
Cool. Oh yeah.
I'm doing a lot of hopping between different things, so it's like but yeah, if that kind of stuff comes up, everybody feel free to just, take yourself off mute and let me know. I'd rather have us have an interactive, successful session. So if you're going to go ahead and do the RStudio R Markdown option, I want you to go ahead right now and run this first line of code, and I'm going to show you how to do that. And that's because if you don't have the packages installed, they can be installed and loading while we're going through some of our slide work. All right, so you run code just by running this current chunk right here, right? And I'm getting a warning, our tools is required. That's okay. I just moved into a new computer and I don't have it all fleshed out yet, but I know it's gonna run fine. If you're getting different errors and you can't troubleshoot them, this is where I'm saying you probably just wanna go with the HTML page. Okay, now we're gonna screen hop again. Okay, great, thank you. So before I jump in, are there any major questions that I can potentially help with about accessing the materials? Wow, I'm gonna hope it's because everyone's refilling their coffee. I'm gonna assume it's because everyone's refilling their coffee and not because that actually went smoothly. And as it says on the GitHub page, if you're not able to access the materials at all through those download steps, just click on that link and that will take you to an RPubs document that's just the HTML. So you have 17 different ways into this code, and I'm hoping at least one will work for you. All right, so without further ado, jumping right along. So the flow of this workshop today is going to be, we're going to do a little bit of concept review, but I had the great opportunity to sit on Dr. Namova and Dr. Tanya's lectures this yesterday and today, so there's not much more that I can say on top of that. We're going to talk about the structure of ggplot and how the syntax of calling that code corresponds to what you've learned about creating visualizations. And then finally, we're going to do our own little troubleshooting where we have a graphic and we want to take it from a rough sketch of ideas and data, but it's kind of messy. How can we make that into a visualization that tells a story? All right, so some of these are going to be a little tongue-in-cheek, so you'll have to forgive me, but feel free to throw it in the chat or bring yourself off mute. why do you normally usually make graphics? Like the top ones that I thought of were for my own use. If I'm looking at data and I want to see what's going on, if I want to informally share something with colleagues, or if I'm developing something for a formal presentation or for a publication. Anybody have anything in addition to that?
Got a few folks have said exploratory data analysis, maybe trying to see some patterns, reviewing some distributions. But a lot of people are saying either 1, 2, and 3, or 2 and mostly 3.
Cool. Well, hopefully by the end of this, 1 will be part of that, because the process of making graphics won't seem like such a task. So then the next one is, how do you normally make graphics? Like if you do make graphics, are you using something quick and accessible like Excel? Are you using a statistical software package that might be a little bit more expensive, but also have a lot more constraints to it? Are you using something like we've heard of today, like Tableau, some base R, or like starting to work in ggplot? Or do we have some pros in here that are going to teach me a couple things about R, as well as Python and something else? So what kind of tools do you most frequently use, and what's your thoughts on those?
So far, folks are also responding to the previous slide, Meg.
Oh,
We
cool.
have a few folks saying that they want to convey info to stakeholders in an accessible way. Some folks are saying they're making visuals because they're told to, which probably makes a good sense. And I think a lot of folks are focused on using R for exploratory data analysis. Some folks using ggplot if they want to really refine their graphics. And many folks are using Excel for just kind of like quick ideas, or Tableau and Python for some of the more intricate types of analyses that they have to do.
Awesome. Great. It sounds like we've got a great range here. All right. So then these are kind of redundant if you were in a couple of the previous lectures, and also, again, tongue in cheek. So what makes for a good graphic? Is it really busy with every detail in text and showing as much information as possible? I think someone's off mute. Is it really flashy plotting? Or is it a clear message that tells a story? What do you think makes for a really good graphic?
We had a couple votes for 3 right now, a clear message. I think we're still waiting for folks. Some folks are saying that there's kind of pros and cons in different software. So they kind of use different softwares maybe for the different types of messages they're trying to use. But a lot of folks are really into telling a clear and good story.
Cool. I'm sorry. And I set you guys up for that one. And you'll notice I definitely set up. There's actually a website called Useless Charts. It's the most useless charts ever made. And that's where I got this one right here. So if anybody's ever bored on a Monday night, uselesscharts.com. All right. So today's goal is to understand how to develop graphics that effectively tell a story in ggplot with a little peppering of tidyverse in there, and are refined to highly refined. And we are going to start right in with a little refresher on the foundations, but not too much. The basic foundations for data visualization development is you need data. And then, an understanding of the structure of your data. Do you have continuous variables? Do you have discrete variables? Do you have count variables? What does your data hold? And then when you're thinking about visualizations, and particularly in ggplot, you also need to then start thinking about the format of your data. Do you have all your data in individual columns? And that's called wide data, or do you have long data? Do you have data where you have a single column that captures a lot of variables? Now, the reasons for this is going to become clearer later when we start developing graphics that have a stacked aspect to them. But for now, that's just something to keep in mind. The other thing to keep in mind is the graph attributes. you know, what kind of dimensions do you have? What kind of axis scales do you have? And are you using symbols, colors, schemes? How are you communicating this story? And then finally, we want to consider the key elements of the graph. And these are the titles in the graph. You see, I have a very catchy title. I always recommend a very catchy title. And then you want to have your labels axes labeled. And then, you know, occasionally you can do some embedded comments. You can highlight something. You can show significance if there is a statistical test associated with your graph or your story. And we can explore and develop all of these in the tidyverse. So the tidyverse was originally called the Hadleyverse, and I am very partial to the tidyverse, and here's why. The tidyverse is a collection of R packages with shared philosophy, shared structure, and shared syntax. Now, what does that mean? It's basically a bunch of functions that act as verbs, and you can pipe those verbs to the subject, which is your data. We're going to show all this, and do piping of your data using this common readable language. And some of those packages include Reader, which is a very clean way of importing data, dplyr, which has a whole suite of functions for cleaning data, lubridate, which I can't imagine working with date time without it, stringer, when you want to work with characters, and then of course, ggplot. So ggplot was originally developed by Hadley Wickham. It's over 10 years old. It's been through many different incarnations. They always say it's gone as far as it can, but there's now 84 new extensions, which I find to be incredibly useful. It's readable compared to base rplot for plotting. And it's based on this book that came out a while back called The Grammar of Graphics. Now, you don't need to read The Grammar of Graphics to understand what the syntax of ggplot is, but just understand that ggplot actually stands for Grammar of Graphics. And what it does is it takes the 8 main classes or the 8 main groups ideas that are outlined in this book of how to develop good visualizations, and it provides coding syntax for those that align with key elements and attributes of graphics communication. So how that looks is, if we think back to our foundation, we have our data, and within ggplot and syntax, there's corresponding arguments for data, for functions, and for coordinates. For graph attributes, we have our mappings, our geometries, scales, and facets. And then finally, in our key elements, where we can capture different things like themes by titles, axis labels, and embedded comments, those are our theme arguments. Okay, so at this point, I am actually ready, I don't know if you are, to dive right in and start working with what all of this means and try out some coding. Here are your choices in the slides. I'm going to be showing what the code is, which is how you call this particular argument in ggplot2, the considerations that go along with this argument, and then what is programmed within the argument itself, so that you know how, what, where, when, and why you want to use that particular argument. Like I mentioned, you can follow along in the HTML, but I'm not going to be switching back and forth between the HTML. I'm going to be switching back and forth between the slides and the notebook. If you are going completely Wild West and you want to run code, it should work. I've had some people test it, but that is really up to you if you've had experience working with our code. I highly recommend the notebook if this is newer to you. Before I jump in, do we have any questions that I can help with?
So far, it's looking pretty good, Meg.
Again, like I said, that's either good or bad. All right. So you can follow along and keep track of where we are based on, here we go, laser pointer, based on this little menu on the slide. this is going to track exactly which point in the code we're at. So we're going to start right in with data. So when you're working with data in R, there's a whole different range of ways you can call it. In the tidyverse, the convention is to specify the data frame as your subject, and then you pipe it along to a series of verbs. And each one of those verbs will have an action for your data frame. What does that mean? When you're working with this data frame, you want to be sure that you already, like I said, have in mind, is your data discrete or continuous? Because this is the data that's going to coincide with your coordinates. Is your metadata discrete or continuous? Because that is going to affect what kind of colors, shapes, etc. that you can map to. This is also where you want to be cognizant of missing data. If you have missing data in your data frame, that's a story for another time, but it can really wreak havoc on your code. Because as you can see, each thing has different arguments and different specifications, and some arguments don't allow for missing data at all. As I mentioned, this is where tidyverse can be really useful, because you can do your transformations and your reshaping as you pipe it directly into your visualizations. And you can also run something that I really like, which is a structure check using this tidyverse package called skimr. And as I mentioned, you can invoke this in a number of different ways. You can call the function around the data frame, or you can pipe the data frame along your sentence through a series of verbs. And I think, yes, and as I mentioned, this corresponds with the foundation of graph data. So we're going to do a screen switch, and we are going to go over to the ggplot workshop. Maybe. No, that didn't work. All right, so you can see my whole screen now. Okay, great. And now you can see our studio. Beautiful. All right, so hopefully at this point, if you are following along in the notebook, you have installed the tidyverse skimr and our color brewer, and we're going to load those packages into our environment. We use the function search right here to show that we do in fact now have all of these packages at our disposal. So the data that we're going to work with today is iris. I thought long and hard about this, what the best approach was. I considered, I had some neat nutrient data sets that I downloaded from Kaggle, which is a great resource for datas. But for the purposes of coding, iris is one of, I think, 15 data sets that comes preloaded in RStudio. And this is really a really powerful tool for you as someone who's starting your ggplot and R skills development, because most of the time when you are searching for solutions to an error that you've encountered, it's going to be you using one of the standard RStudio data frames. And 9 times out of 10, it's going to be an iris. So my decision to work with iris here is that when you encounter problems, you can use this code, you can use the standardization of iris to troubleshoot if the problem is with your code or if the problem is with your data set. So I do apologize that it's iris, which is, as you'll see now, a standard data set that describes the sepal length, sepal width, petal length, petal width of 5 species or 3 species of flower. And when we run this skimr function right here, and as you can see, I like to stick with the convention of piping my data frame to the verb, we get this great table that shows the structure of your data set. It tells you how many rows you have, how many columns, what types of variables you have. In this data set, we have 1 character variable, and that's the species, and it's got 3 variables within it. And it also gives us the breakdown of how much of each of those that we have. And then we also get descriptions of our continuous data as well as histograms, so we can see the distribution of it right off the bat. So this, to me, this package was a game changer. I don't do much without looking at my data through this pipe first. So the next thing I'm going to show you, having to do a little bit with the tidyverse here, is we are just going to add another variable into our data frame so we have something else to play with. And I'm doing that here by using the dplyr function mutate, and then I'm just creating a new column called trial. Right, so that should now show us that we do in fact now have a new column called trial. Yay. Okay, so the next thing that we're going to jump into is the ggplot function. Back here, here, and function. Okay, so as you'll see, the ggplot function, when we call the ggplot function like this, piping the data straight to ggplot, we end up with an empty graphic. ggplot is just a function, and what it does is it calls the plot object. And the best placement for where you set your data is kind of up to you. It depends on what you're trying to do. The arguments within ggplot, it's looking for your data, which you can pipe through. It's looking for coordinates. These can either be X and Y, or just X or just Y. It depends on the geom that you're using. You can also set your mappings here. This is if you have additional variables that you'd like to have a scale to. This will become clearer later on. And the different ways of calling this, you can call ggplot with the data inside it. You can call ggplot and then specify the aesthetics, excuse me. You can call ggplot and then specify no aesthetics because you want to do that in the geom shapes later on. Or you can pipe it through the way we've been doing. And that, where's my screen? Oh my, that's not where we want to be. Well, that's going to mess everything up. Okay. So as you can see, we've got our iris clean data set. We're piping it through to the ggplot function, and we get just our plot object, nothing in it. Now we need to And if anybody has any questions while I'm going through screen changes, it's a really good time to ask. Okay. So that is function. Now we're going to jump into coordinates. So you specify the X and Y of your data in the aesthetic wrapper. And that's literally what AES means. It means aesthetic. So now we've got our data frame. We've got our ggplot call. This is the notation for when you're piping your data. And then you specify aesthetics. I want my X to be this column, and I want my Y to be this column. And in this case, you can see we're doing trial and sepal width. But again, because we haven't started assigning geoms to this, we're moving up a little bit, right? Now we actually have a grid line and we have information, but the ggplot function doesn't know how to display that data. It just knows that there is data coming that's got these X and Y attributes to it. So considerations with this is we want to think about the data positions for the plot. Where do you want your X? Where do you want your Y? It's not always necessary to specify this aesthetics here, but it has to be supplied somewhere in your geom layers. If you have continuous data or discrete data, it's going to set your axes on different scales. So coordinate data will be according to the coordinate, if continuous data. So if your data is 1 through 100, you will have 1, 2, 3, 4 through 100. But if you're working with categorical variables, say for example, 3 types of flowers, those variables are going to be 1, 2, and 3. This is really important when you start trying to build layers into your graphic. Because if you want to be able to add labels and markers, you need to know what coordinates you have in your plot itself. This is also important. ggplot is going to put your character variables in alphabetical order, but be careful if you have your variables in a factor class, there's going to be underlying levels that might have been decided for you. And when you're trying to figure out why it's putting things in certain orders, you're going to have to untangle that to figure it out. The arguments for the aesthetics, like I said, is X and Y. These are positional. You don't necessarily have to specify X and Y, but just know that whatever sits here, ggplot's going to read as your X, and whatever sits here, ggplot's going to read as your Y. And you're going to just get your blank plot with your axis set up. Okay, so the next step on the hike here is mapping. So if you have, for example, a variable like flower type, and you want your columns, bars, points, whatever have you, to be colored in accordance with the color type, what you're doing is you are mapping to that variable. That's what it's called. But basically, you want to add another layer of understanding to your data. You want the viewer to be able to not only see the X and the Y relationship, but you also want the reader to see its X and Y, but also these colors. So when you're doing that, you have to specify that within an aesthetic. Otherwise, you may have seen it, if you specify it somewhere else, you're going to get a color named flower type, but not any change in your colors. So when you're choosing an aesthetic, this here, this space holder, can be your color, it can be your fill, it can be size, shape, line type, transparency. Just keep in mind when you're choosing these, you have to know if your data is continuous or discrete, and you have to understand what you're mapping to. Just like with the others, ggplot gives you a lot of freedom. You can map wherever you want. If you're only doing one layer of geometries, you can map within the aesthetic next to the coordinates, but you can also take this mapping and you can put it specific to your geom point. Like I said, if you map outside of the aesthetic, or if you put the aesthetic in parentheses, it's going to take what you say literally, and it's literally going to try to find a color named var1. And here, the only color you're going to get is the color black.
Meg, one question came up about if you were going to use color brewer, how do you select colors that are colorblind safe?
Yes, that is a very good question. That is absolutely something that we're going to come to as soon as we get to the scales section. So we're going to now jump into geometries, where we're going to start actually being able to see something in our plots. And then once we have those geometries, we're going to use scales to really have some fun. Sound good?
Sounds great. Thanks, Meg.
Awesome. Thank you. Thank you for the question too. Okay. So geom, this is where we start getting into trouble and having a lot of fun. So now you can see, we're finally starting to see something on our plot here, right? So you've got your data, you've got your ggplot function, you've got your aesthetics, you've mapped your X variable on what's on your X-axis as the trial column that we created. And then right now we're using sepal length as our Y coordinate. And we've also mapped to var1, and in this case, var1 is species. So when you're working with the geometry component of ggplot, you want to, again, think about what kind of visualization is the best approach. And like I said, this has been covered by really great lectures. So I'm going to leave that there and just say that you have so much at your disposal with ggplot. Largely, they can be grouped as reference lines, bar charts, dots, and points, box plots, heat maps, maps, density, polygons. You can add jitter, you can add error bars, and then you can even map to texts and labels.
And Meg, in the color, in the slide previously, slide 24, you had provided a bunch of different colors as kind of like a heat map. Are those all the colors that are available to us in R, or are there more colors?
No. Again, I actually have a section in the scales about colors, because I think that that's one of the things that we most often want to do with our graphs, but also B, I think the way that it's documented and coded, it can be the most confusing. So when we get to scales, we'll get into how to specify, but for now, know that when you don't specify a color scale, R will choose one for you because it's very helpful. And its default is to choose from the rainbow color scale, which is great. But what happens with rainbows is it will recycle. And so you can end up, if you have like 100 variables that you're mapping to, you can end up with variables that have the same colors. Also, as you can see, this is showing us something, but it's not necessarily showing us maybe in the way we want to. And we've also just got ourselves a great default ggplot on our hands right now. So these are the default colors. It's using the rainbows palette, but when we get to the color scale section, we're really going to dig into a little dirt there. All right. So there's over 40 individual genomes. It's a different lecture. There's 40 individual geomes over 40 within that group. There's lots of really great resources, especially the R graph gallery, that can get into what all of those different ones look like. The big hitters, obviously, geome point, geome histogram, geome bar, and geome column we're going to cover today. And like I said, you can build the individual mappings into these geometries. You can add multiple geometries on top of each other and have layers. But what's really important is, like everything else within these, know what arguments the function is expecting. So when you have your geome, fill in the blank here. What's the mapping? What's the data that you're using? Is there a default statistic that's being applied? Are they using a count? And what position does it put the data in by default? So now I think would be a really good time to jump into some actual coding to take a look at what this looks like. And perhaps my R will behave. Okay, everyone see my screen? Yay. All right, so because I had these slides and because the hopping is a bit busy, you can see this is our coordinate plot. This is what our mapping plot looks like, still nice and blank. And then we get to our geometries, and we've seen this code. We have our coordinates, we have our mapping, and in this example, I'm using geome histogram. Now, I know that geome histogram works with count data and that it's only looking for one coordinate, so I've only specified one coordinate here. I run that, and we have our first plot. So a couple of things that you can think about here is we specified color, and somehow we got these weird highlighted outlines. That's probably not what we wanted, right? And the other thing to think about is what would have happened if we had specified an X and a Y? How would the geome histogram react to that? So that I will let those of you who are coding play with. But the answer is The color sets the outline, but in this case, the geome's looking for fill as the argument to fill. And it's also telling us that we should perhaps consider a different bin size. So ggplot can be very helpful. So maybe we want to go with the different bin size. Where are we going to specify that? And where should that argument go? Does anybody have some ideas where you think that I should use the bin size? Should it go within the ggplot call itself, or is there a better place for it? Spoiler, it should go here in the geom histogram. So I'm not going to do live coding because not going to work. But I will show you that now we have our species set to fill rather than color. We're still going to get a suggestion for different bin sizes. Let's just try it. Hey, so as you can see, what's really great is when you are trying to add something in, you're going to get these helpful pop-ups. So RStudio knows that one of the default arguments of geom histogram is bin width. So I'm just going to go ahead and let it auto complete that for me. And I'm going to try a bin width of 20. And I'm going to hope that it's looking for a continuous variable. Cool. I don't like that so much. So I said, thanks ggplot. I liked my bin width the way that it was. I'm going to go ahead and delete that. And now we have a stacked histogram colored by color, or filled by the species, because we're mapping to that aesthetic. So here is a moment, if anybody wants to take a try at a different geom. We're going to skip this, but if you're working within the R notebook, think about this in the future. If we want, we can, we have the fill specified, but we can add an outline by mapping to color. And right now we're mapping to color in species, but then outside of it, we're setting an alpha. So we're setting a transparency. And when we do that, you can see that the mapping still works. We get this outline. We get the same transparency for all of the variables. And the transparency is affecting the fill, even though the fill is in a different function. Okay, so we're going to skip down to line 124, and we're going to try making a bar chart now. Bar charts can have an X and a Y, right? So we're going to try to do the data by trial and the sepal length, kind of like what we've seen, and we're going to fill it by species. But right now you can see I have the stat set to identity. Now, why do I have the stat set to identity? This produces what we want. But the reason I have the stat set to identity is because geom bar is actually the same basic function as geom hist. It's looking for count variables. So if I want to get the actual data itself, I have to set this stat to identity. This is this extra line of code. If I remove this, I'm going to get an error because geom bar is like, what's my stat? I have an X and a Y. I can't map that to counts. But that's okay. We have geom call. Geom call is the default for actually making the XY bar charts that we want. The default here is actually identity of the data, so you don't need to specify it. So with a lot less code and a lot less thought, we can just really quick make our stacked bar chart. But I don't really want to look at a stacked bar chart. I want to look at my data next to each other. So one of the arguments that we know that's built into geometries is the position. So I'm going to set the position to dodge rather than stacked, because stacked is the default. And now I have my data side by side because the position argument within the geometry is set to dodge. How's that? Is that all pretty clear so far? Cool. Okay, so the next thing I'm going to jump into is scales, and because we're running a little short on time, I want to have enough time for the colors and the scales that everyone's interested in. The next chunk of code is yours to do with as you please. Try out some different geometries and see what happens. You can fill in your own code, you can try out different geometries and then run them, get errors, and try to troubleshoot them. But let's hop back over to our PowerPoint. And we are going to jump into scales. So scales is where you can now start specifying your arguments for your X and your Y, what you want to see on there, but also your colors, your shapes, your fills, that kind of stuff. So this is where the arguments for what you've specified in the aesthetics, the data, and the mapping, this is where it goes. You can set your arguments for your coordinates, and you can set arguments for color, fill, alpha, line type, on and on and on. There are different commands for different types of data. So if you have discrete data, you're going to have to use a different command than if you have different continuous data. And then there's also a bunch of these scales that are commonly used defaults that are pre-built so that you don't have to build them up from scratch. The arguments within scales, you call your scale, you specify what type, what you're scaling, and if it's continuous or discrete. And then you can name it, you can change the breaks, you can change the values. You can change your labels, you can change the limits of the plot, you can choose transformations, so you can specify log transformations here, you can tell it whether or not you want a legend here. And then you also can specify, like we've seen before, the position.
It's a quick question to the position. If we don't set the position, will R use its default position, or is it the position that you use in your last configuration?
If you've specified position elsewhere, then it will carry through. Great. So you want to be cautious not to set the same arguments multiple times, because R goes in order of how it reads things, and it's going to read the last call you make. So if you set it the way you want it somewhere else, and then you change it later on, it's going to either throw an error and tell you you have two arguments, we're not proceeding, or it's not even going to tell you that you have two different arguments, and it's going to go with the one it sees last.
Awesome, thanks.
Yeah. All right, so the standard way you scale your axis, scale X continuous, scale Y continuous, scale X discrete, scale Y discrete, and all those arguments are encompassed within it. And then you have pre-built for your custom axis scales. You can do log transformations that are pre-built. You can reverse your axis, so you don't have to specify that within your argument. You can run square root. They've got date time, on and on and on and on. And then you can also, like we were saying, you can scale your transparencies. You can scale shapes, line type, all the mapping options. The difference between the coordinates is that when you have continuous, it's continuous, but in this case, it's not manual, it's discrete. Scale alpha discrete, scale shape discrete. All right, so now we're at colors, and it sounds like this is where people want to be, and we're running a little tight on time, so hopefully we can get what you're looking for. So as we saw, there's differences between specifying color and specifying fill, so definitely be cognizant of that. And then also definitely be cognizant of the difference between your data types. If you're trying to set an argument on continuous data with a manual argument, it's not going to run, and your color is not going to work, and you're going to wonder what's going on with my colors. So this is where you can specify your own palette of colors, but as we've said before, there's also a wide range of pre-built, one of which being brewer, and there you can hit your scale fill brewer or your scale color brewer. So I will show you now how that works. Oh, did I stop sharing my screen? What did I do? New share, our studio. There we go. Scales. Okay, so within this chunk of code, I have a couple of different ways that you can change your X and your Y scales and some troubleshooting for you to do. You can do that as you please. The first thing that we're going to take a look at is all of the colors that are available to you in R. Ready? No, we're not done yet. We're not done yet. No, we're not done yet. No, 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 no. Hold on. There we go. So that's fun, huh? There's actually a really great package I'm going to tell you about now that will make your life a lot easier. You are going to want to install a package called Color Picker, and then it's going to install to your add-ins. You go to your add-ins, you click on Color Picture, and you get a GUI. And from this GUI, you can pick colors in R. You pick any color you want, and it will create a palette for you. And here is all of those colors that just printed out, and you can see them. And all you do is you just click, 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 click. So now you know how to pick your colors, but where do you set them, right? Once you finish with this, you press done. It will give you a vector of colors. And what that looks like, what that vector will look like is this. This is what we call a vector of colors. So in this example, I picked Plum 2, Lemon Chiffon, and Sky Blue 3, because I was really excited to see what those colors look like next to each other. So I've got my scale color manual, and I want it to be scale fill manual. That was troubleshooting. I did that for you guys, don't worry. All right. So using the values argument and scale fill manual, I've changed the color palette here. I now have Plum, Lemon Chiffon, and Sky Blue.
And is there a specific package that you use then for the color picker? Is it color picker? Is that the package?
That package is literally called Color Picker. Yeah.
Okay,
Yep.
great.
So you're going to want to go ahead and install that package. It's not part of this because it takes a little while to install the GUI. So it wasn't more demonstration than application. Okay, so Color Brewer. Here's Color Brewer for you. What we're going to do is we're going to make this call called Display Brewer All. And what Brewer is going to do for us is it's actually going to show us what palettes we have at our disposal and the names of them. On its website, our Color Brewer actually specifies which palettes are colorblind friendly or not. That information's not here, and I can't remember it off the top of my head, but they do have a wide range of different palettes for you to use. And they have, and they all work in different situations according to like what data, what relationships you're trying to choose. So in this case, for our fill, I chose set 2, and the way you specify that is scale fill brewer, because I'm trying to fill and I want to see set 2. And it runs, and now we have the 3 colors that Brewer chose from its palette of set 2. We also have some points in there. That's part of the lecture and the materials that you can explore later on. Okay, real quick, we're going to shoot through facets. So faceting is just a different way to demonstrate relationships in your data. There are slides for this in your code that go through a bunch of the different things, but here we're going to apply this argument facet wrap by trial. And when we do that, now instead of all of our data being next to each other, we have all of our data in individual windows. There's some issues with it that you need to resolve in the defaults. And so we've specified that here. We want our scales to be free ranging. We want to potentially look at it in rows, and maybe we don't want the strip that has the thing at the top. So we're going to run that as strip position right. And now we can see we've adjusted the default settings for scaling. Okay, so this last section right here is on themes. We're just gonna hop back over to the ggplot workshop for some themes. Okay, themes can be a pain. You can see that you're starting to get towards where you want your relationship to look like, your story to look like in your data, but it's still not pretty. And so some quick ways that you can do this is through the theme argument. So themes encompass all of those plot elements, and the four main modifiers to themes are the line modifier, the rectangle modifier, the text modifier, and the title modifier. Luckily for us, there are pre-built themes that are available, and there's also a great package called GG themes, and this has a whole bunch more themes that you can access. So this is what the main modifiers look like if you want to go it on your own and try out some theme changing on yourself. If you're dealing with an item that's text, you're going to call that item an element text. If you're dealing with a panel, element rect. So if you want to change the background, if you want to change the grid lines, this axis, this is where you can rotate your fonts. This is where you can change the text of your fonts. You can change the size. And then your titles. So these are all the titles for your X and Y axis, for the plot itself, for your legend. And this is what's available for you to change. So really the world's your oyster, whatever you want. There's an unlimited supply of things that you can change in your ggplot defaults. I definitely recommend starting with some of the standards and building up from there. So we can take a look real quick and see what that looks like. We'll try theme minimal out. So you can see we've built our plot. We've got our theme minimal. We're going to run that. And we can see between this one and this one, the changes are there. They're not great, but it's better. In the next example, I actually show you some of the ones that I commonly use. So I want to change the legend text to be bold. And I'm doing legend text, element text, as we discussed, panel grid, and I'm making that blank. And I'm making the other grid blank. And then I'm going to change the color of the lines. So there's like a sampler of all the different options that we want to play with. So we do that. We've changed the font. We've changed the grid lines, we've changed the axis color, and now we start to have something that looks like a sketch of our data. Okay, so this last part right here is definitely something that you guys can work on using the code. So this next part right here is something that we're all kind of familiar with. You show this great plot that you've worked so hard on to your advisor, your boss, your colleagues, somebody, and they say, it's good, it's not quite telling, it's a sketch, it's not my story. I have this list of demands, here's what I want to see changed. I don't want to see facet by trial, I want to see the facet by width and length. And I do like the bar graph, but I want to see, you know, the trial breaks labeled as years, not 1, 2, 3, 4. I want different scales on my axis. I want to ditch the points that we put in there. I don't like that. I want the species names in italics. I want no gray in the facet boxes. And I want to try out a new font. I don't like the font that you used because I want the plot to look like this, right? So in your code that you have, 2 minutes. If you guys have to leave, I totally understand. There's like 2 minutes left here. Look at RStudio. In the no hints option, here are your lists. Here's what your advisor, your boss, your colleagues want to see happen. And there's no hints here. So you just modify this font, this code. There we go. And see what happens. How do you change it? How do you take what we've taken from those 8 elements of ggplot and start changing this stuff? In the challenge hints, I've actually started providing them some hints. So for facet width and length, this one might be a little tricky because we didn't really cover this, but it's in the tidyverse, and you're going to want to use the argument tidy or pivot longer. And that's going to melt your data into long format. You want to use the bar graph, but make sure you're using the right one, geom call or geom bar, which one's better? And on and on and on. Species in italics, we want to modify the theme. And then within here, I've hashed out everywhere you're supposed to change these components, right? There's a lot of demands in there though. So if you've had enough and you just want to see what it looks like, this final one around 425, this is the clean code. This is moving from sketch to story. And when we run this, I love when it runs clean. You can see we end up with a very different graph than we had before. We'll do one last screen switch. Okay, so we've moved from our sketch to our story. This is what our graph looked like before, and this is what our graph looks like now, right? I'd say it's kind of close, considering that this I kind of sketched out in PowerPoint, and this we actually coded and specified all the attributes of this using ggplot syntax. But that was just one round of editing. That was my attempt. There's plenty more to be done, and that is where you can go with it from there. What would you do next? What would you improve? What would you make prettier in this plot? So for some troubleshooting, we've gone through, I've done a lot of examples in that code of different ways to troubleshoot data, throw errors, and then see what happens. You want to always consider the class of your data. Is it count or continuous? Your order matters, layer, layer, layer. So if you're doing multiple geomes, the last one you put in your order is going to be the first one that appears. It's going to be the least transparent. What are the arguments of your function? Are you invoking a discrete call on continuous data? It's not going to like that. Did you set the color when you meant fill? Did you specify multiple arguments for the same item? See, we run into this one a lot. And then the last one seen will be the first one that shows up. Here's a lot of resources. And hopefully after this, you understand a little bit more clearly how to effectively tell a story in ggplot and some tidyverse to produce graphics that are refined or highly refined. You already know my GitHub page, but come find me on LinkedIn. Everybody tells their Twitter. I guess I don't do a lot of Twittering, but I do have one. So connect with me on Twitter. And, the question in R, as you can see, is not if it can be done, but how. That quote is not mine, but I couldn't find the person to attribute it to. So find me on Twitter and tell me who I quoted without quoting them. From there, if you still have time, I have time. I ordered delivery tonight and it's not coming till 7:30, so I can hang out.
Perfect. Well, as always, a huge thank you to Meg. Again, a wonderful friend, an even more wonderful teacher, and has been absolutely wonderful to put this together. Meg, we do actually have quite a bit of questions for you, or at least a couple that came off the bat. But more importantly, there's been a resounding thank you from the entire group here for making this very easy and understandable for a topic that is usually quite challenging. I've gotten a few comments saying that students are lucky to have you. And with that, I also want to say very lucky to have you as a good friend for sharing all of this with me. So a few of the questions that have come in so far, you had mentioned the difference between geom call and geom bar. That was a big question that came up. And also, how do you create maps in ggplot? I know we had kind of briefly touched on it and we had to run through it, but are there other packages that you tend to use when it comes to making maps? So two just, tiny topics, but if you just want to kind of briefly go through them and just give a little intro or direction where we can go for that.
Yeah, absolutely. So I don't have any map data up. Can you think of what's the default?
So at least from the maps that I've made, I
Oh, no, I
know.
mean, what's the default? There's a data package that's a default in R that has coordinates in it. If anybody comes up with it or wants to do a search for it in the background, I'm happy to try some live coding, but I know that R does have a default data set that's got longitude and latitude in it. The package that I use almost to exclusion when I'm working with mapping is the geom_sf package. And that is an add-in, and it looks like this, right? So, and as you can
We're
see,
not seeing your RStudio.
Really? I just made a beautiful map. My computer must be dying. Oh no, I have to go. Let me try. Okay, can you see it now?
Yep.
Cool. All right. So, like I said, I rely very heavily on the prompting in RStudio. When I have to work with R outside of the RStudio environment, I feel like someone's taken away like my thumbs. It's very difficult. GeomSF is the function that I use almost to exclusion when I'm working with mapping. And as you can see, you just specify the A and the X and the Y, and that'll be your longitude and latitude. And then it just kind of invokes along all the same arguments that we've discussed before. There's a wide range of packages like that are available where you can plot on top of pre-existing like satellite photos, or these are I could try to pull up the code that I have for that, but there's some great resources out there, and you can either then using the GeomSF, you can either pull shape files from a resource. So say you wanted to plot, county data in Texas. You need to access that county data. That's called a shape file, but those are all available online. So you download the files that you need, and there's ways that you can read those. You read the shape file into R the same way, and it'll appear right here. And then just as we've been showing, you just layer that in. So you read in your shape file, and then you can use GeomSF to fill those shape files with polygons, the way that we filled the rectangles in the geom bar. You can also then, because you have your shape files and the shape files have their coordinates, let's look at coordinates at least.
Meg, the default data is called world, and I just put info about it and a link to it in the chat.
Beautiful. Let's see. Is it world or World Bank?
I think it's world, but you might have to download the library R Natural Earth or Natural Earth.
Yeah, so those are going to give you. Yeah, this looks like this doesn't have any latitude and longitude in it, but latitude and longitude are an X and a Y. You just think about it as that X and the Y, right? So this would be longitude, and this would be latitude. Yeah, good, cool, long day. And you can imagine if you have the shape file for your counties, it's going to overlay those counties. And then from there, it's just the same. It's just layering geometries on top of it. So a geom point, if you wanted to put like specific places on there, and if then you wanted to scale those points by population size of those places, scale shape manual, scale shape discrete, scale shape continuous, alpha it. And then you want to, add a layer of polygons. So you want to have like the background. So you use geom polygon, and you're going to fill those polygons according to the shape file of the counties of Texas. There's a tutorial online specifically for Texas, GeomSF and Texas data. And I think it's gun data, either ownership or violence. And if you can't find it, then just reach out to me through any of the mediums, and I'll point you that way. As far as the geom bar and the geom call, that's, I don't remember the question, but that's one of those examples that's really easy to point to of knowing the defaults. And it's kind of splitting hairs, like which one's better than the other. People who are very proper about their coding, and the best code is the lines that have the code that has the least amount of lines. If you're in that kind of headset and you want to use an XY bar plot, then you probably want to use geom call. If not, use geom bar and just change the stat to stat identity, because the default in that one is stat count. And you can find that stuff by doing question mark geom bar. And what that's going to do is actually pop this resource up for you in your window here. And it already tells you here the defaults, right? So the stat is count, the position is stack. So this is why you're going to get the graph that looks the way it does when you use geom bar versus if you use geom call, right? No, it gave me, oh, there's call. I was about to say, it made a liar out of me. But here's your geom call. So it doesn't have a stat default set, right? But it does have a position stack default set.
And as an extension, I have a really fun question for you, Meg. You might have a little PTSD after all the ones of these we made before. Interactive maps.
Oh, yeah.
Interactive maps. So are there specific packages, or what is your strategy for tackling those monsters?
Yeah, we've actually, I don't think I have the example. I don't know. It's like I said, I moved into a new computer, so I don't have the code like quick to find. But for animations, for making something dynamic, I swear by the ggAnimate package. Again, it's an extension of the ggverse, tidyverse. Can you guys see my screen? I'm out of RStudio. Can you see that I'm out? Cool. I actually have this live for you. Okay, and here's ggAnimate. And you can see ggAnimate, right? It invokes the same arguments. You use the same aesthetics to build it. And at the end, when you have your ggplot all made, so you make a beautiful geom SF, you make your map, you have it beautiful, and you want it to change between years, for example. That's the one that we've just produced, where we have our fill set by polygons from our mappings, from our shapefile, and then we want it to shift between panels between years. And we don't want to use a facet. We don't want 200 facets. We want it to be dynamic. So here's this should look pretty familiar at this point, right? Your ggplot call, your geom box plot. Here's where it changes. You just change the transition states. It's got a bunch of different arguments that you can call, how long you want it to take, how you want it to enter, how you want it to change, and then how you want it to ease in and out. And there you go. You have a dynamic ggplot. It's crazy, right? This is why I love the tidyverse. This is why I love ggplot. There's other packages out there in the world that will do animations for you. And they're good. They all have their strengths and they all have their weaknesses, but I try to stick to the ggplot world as much as I can, because it's so, the language to change and modify things is so standardized. I get a beautiful animation and I want to change the font, and I'm going to spend 2 hours trying to read documentation if it's not in ggplot. And at this point, I value my sleep. So here's another example, right? So this one, they used a data set called Gapminder. They have their transition time set as year. And what happens when you set what your transition time is as a year, it's going to give you this cool little widget up here that actually tells you what frame you're in. You can change the title. You can change how rapidly it goes. You can modify that title and how it changes throughout. So that's GG Animate. Very well documented, very straightforward. The only thing I will hazard is that if you are creating a graphic that has hundreds of individual facets to it, the amount of time it's going to take to render that graphic gets exponentially larger. And if you don't have a computer that's got a really strong GPU, you could spend hours waiting for it to render. And I have a new computer now because of that.
I can personally attest to the rendering time. That may have been my fault. But what I can say is that you've just blown the socks off to most of us, because GG Animate is just such an amazing package that none of us had seen before. So thank you. And to also make sure you're able to sleep at night and not spending all of your time coding. Steps, tips, tricks, exporting. We didn't really talk about exporting maps or graphics, but when you export them, how do you export them in a way that retains their quality so that they can be then embedded into a Word doc, PowerPoint, wherever you want to throw?
Yeah, no, that's really important. I don't think that gets nearly enough attention because, you know, I think with files, right, with plots, it's got this handy dandy little export thing. So if I had a plot in here, I could save as an image, same as a PDF, copy, right? But we lose all the fidelity. One of the things that irritates me the most is that when you save a plot in ggplot, it saves it the size of your screen window. And the quality is really low, even if you save it as a PNG or a JPEG. So this is irritatingly straightforward. GG save.
And there it is.
And within the GG save, you can, as you can see, you can specify what you want to call it. It automatically invokes the last plot that you created. So it does inherit that from the plot basics of R. You can set your DPI, so you can set your pixels, you can set what units you want it in. So say you're getting ready to publish in a journal and they say we want all of our figures at 1400 DPI and 3x3. There you go. And you can set, the only thing is I don't know if PNG is a default in RStudio. So I think you have to install a PNG handler, and it's just a PNG package. But JPEG, TIFF, I think even PDF are all in there.
Amazing. Amazing. Well, Meg, again, we all can't thank you enough for this. This is absolutely wonderful. I think everyone has been, again, just through the moon on all the resources that we have. I think with that, that's probably going to be the end, because I want to make sure you're able to have some time to eat your wonderful takeout food. But I think there is maybe one slightly more personal question. I think Liz wanted to chat with you just real quick, but I'm going to shut the video off. I'm going to turn the recording off, and we can kind of move into that. But thank you all again for being here. Thank you all for listening and watching. Meg, again, wonderful colleague of mine, and I do recommend, if you have any questions or concerns, she is an absolutely wonderful resource when it comes to anything R, and especially ggplot. So please do reach out. And with that, thank you all.